Now the point is that it is working on a specific port, right? So these ports are generating, like initializing some services which actually runs that particular server for you. Now you can monitor these services from outbound and inbound routes. So let us let me see a second. Let me open that. Okay, you can see in the Windows there is Windows Firewall with advanced security. When you go in there, you'll see this kind of a dashboard. That's pretty weird. I have all my firewall off. That doesn't matter. I have my Windows. It's just a virtual machine. So there are some inbound rules and outbound rules. Now, inbound rules are the rule sets defined for whatever kind of things are incoming to your system, and whatever things are going out, like the outgoing connections or communication, are monitored in the outbound rules. So if there's something happening that is coming into my computer, like let that be a data stream or maybe a connection whatsoever, so I can monitor it here. So if you see, for example, I'll show you which one. Let's talk about the Firefox private service. So if you see here, this was a protocol that was that was coming in. It was a TCP protocol request that was coming into my system, and Firefox services enabled. So that's okay. I have allowed the action. There was no override being made, and this is the program that ran actually when this kind of service executed. Right. So it was on any of the local port. It can run any on local port. It can run on any remote port. If there was a specific port that was being communicated, it will show me here. You see, it started a UDP request for this was for the DHCP. This was basically for assigning an IP address. So it was communicating with the router, and it connected with the UDP protocol, and protocol generated from 68 and connected to the port number 67 in the router. This kind of communication. This is how you can actually check what kind of responses you're getting from any source into your system. If I want to disallow that, you see the action is allowed. If I simply just make a right click here and I disable the rule, it will disable that. It won't work anymore. But the point is the Firefox is running as of now, so it will work. Obviously, it's running by default. So that's how basically it's gonna work. If I enable it again, come back. If I make a double click here, it will show me this kind of thing that what kind of action I want. If I want to allow the connection or I want to block the connection. If I block the connection, there won't be any sort of connection being made anymore. If I see like there is some sort of incoming connection coming from a unsolicited location or unsolicited port or from some other host, something like that. If I don't want that to happen, I can simply just make a double click on that. Let's suppose if this is a local subnet, if this some sort of connection is coming from their site, I just make a double click and I block the connection and simply click apply. This way I can block whatever kind of activities are incoming into my system, and same goes for the outbound. If there is some sort of data going from my system to other systems or any other IP or any other port, I can simply block and activate that. This way you can actually basically secure your communication over network. And this is somewhat the similar way server system hardening is done as well. Now this was in terms of Windows system. Now the point is of what about a Linux system? If you have a Linux machine, how about that? So I'll show you how it actually works in Linux system. I will suspend my Windows for a while. I don't need that one as of now. So, okay. I'm starting up my Kali Linux for the demonstration purposes. I'll show you how you can implement rule sets in Kali or any sort of Linux system that you have. These rule sets are called IP tables. So IP tables is a very broad spectrum, you can say, concept of implementation of network-based security in Linux system. And most of the servers are Linux-based, and hence you can protect them by implementing these kind of things. You can basically protect every single port and every single service in specific, so that if anybody is trying to access that particular port, or if somebody is trying to attack that particular port or service, you can apply appropriate services or security on that basically. So I'll show you, just waiting for it to start. Okay. I'll pause the video. Right. So yeah, here we go. Now system is turned on. So I have turned on my parrot as well. Now this is another Linux type used for testing as well. So they are connected actually with the same router, so it doesn't matter, they are having the same communication. So the point here is that how this kind of system server security works in Linux. We have seen in Windows, we can see this kind of requests coming in and out, and I can block those kind of connections and requests. How this works in with Linux. Now let's talk about, let's just assume this Kali machine is the server and Parrot is the attacker. Right, and in the server, if I am having a service running for Apache, right? I'll start a service Apache start. If I check the status right now, you see it is not working, it is inactive. But if I turn on the service, you will see it is saying it is active. Correct. Now to confirm that it is active, I'll run an nmap scan on my local server. Check if this service is actually active or not. You can see port number 80 is open, right? The service is active. If I try to check this particular service, what's my IP? 106. Okay, cool. If I run an nmap scan from the other machine, which is having a different IP address, pretty obviously it's having 107. So if I run an nmap scan on 192.168.0.106, you will see it says port number 80 is open currently, right? So it is showing it's open, it's working. Now the point is, if this is open, it is openly accessible, right? The point is that if I want to filter, or if I want to maybe stop or hide the service, how should I do that? Like anybody can scan my network and see like its port number 80 is open. But the point is, how do I secure it? Now, in order to secure it, we implement some IP table rule sets. That's where IP tables comes in action. How they work is basically you type IP tables. There is a proper syntax. I will share the document with you guys if you need. Just ping me out whenever you require that. I have a complete document where I have like complete information how it actually works. So you have to select the table. Now here the table is input table. This is because this request is coming to me. Here I'm securing myself. So whatever kind of input connection I'm getting, that's where I am implementing a security. So I'm selecting the input table by putting -I, initializing the input table. Now I'll give the port, basically the protocol, the kind of protocol that I'm securing for, and the protocol here is TCP, because if you see here, um, right, okay, yeah, you see the port number 80 is working on the TCP protocol, so I put TCP here, and then I give the destination port, which port I want to secure. So D port stands for the destination port. I want to secure port number 80. Now I have three options. Either whatever kind of response I'm getting, I accept that response, or I drop that response, or I reject that response. So if I drop that, accepting the response will be pretty obviously, will accept the response, will give you the details, whatever you need. But dropping the response, we'll see how it actually works. If I hit enter now, it will implement this IP. Okay, let me see. Alright, my bad. I have to put -J. Now J is for jumping. So it is basically initializing all this thing and jumping the response to dropping it. So -J stands for jump, and jumping the response to drop it. Now once I hit enter, it will implement the IP table rule set. Now if I go back into my parrot and I run nmap scan one more time, you will see the difference. Oh, it's taking time this time. You see, earlier it was open, now it is filtered. That's the difference. This is dropping the packet, it's not giving any other information like if it's open or active or whatsoever, it's filtered basically. So might be working, it might not be working. It's not unconfirmed basically. It will not give out any information about AT. So that's how it actually works. If I reject the packet or reject it, scan again, it's gonna do the same basically. You see, when I dropped the packet, it filtered the response, but it gave out a response. But when I rejected the packet, you see it didn't even give a response. It says that all ports are closed, which is technically not correct. It's just rejecting all kind of responses that were being sent on from the port number 80, and hence the attacker does not even know if the port number is 80 is active or not. So this is how reject work. Because if you see, I have rejected whatever kind of response I was getting on port number 80, but my port number 80, that is a service for Apache, is still active. You can see that it's still active. If I run an nmap scan again on my local server, you will see it is filtered but active. You see that it is active, it is available, but the attacker cannot see that. Attacker does not even know if port number 80 is available or not. This way you can secure your ports basically. So that's how it works. But now the point is that attacker can still get to know if my machine is active or not. So how to detect that? It's pretty simple. Just make a ping response, make a ping on the machine. You can see that I'm getting a ping response. That means the machine is active, right? But how to block that as well? If I don't want anybody to know if my machine is even active in this network or not, it's simple. I can block the ping request. Now, the point is how the ping requests work. They work on the basis of ICMP protocol. Right, internet. So ICMP protocol is basically managing the whatever kind of response you get from whenever you're connecting into a network. It's internet control message protocol. Like it basically handles all sort of errors or whatsoever happens whenever a packet is undelivered or if a communication is taking place between two IPs or two nodes in a network. So if I block ICMP itself on my side, nobody would be able to communicate with my ICMP and hence nobody would be able to confirm if I am even active. Right. So earlier I blocked the protocol for TCP, that was transmission control protocol. This time I will block the ICMP protocol right away so that nobody can even know if I'm available. Again, if I accept it, obviously everybody would be able to ping my system. I'll show you in the two different tabs, in a bit more illustrative way. I'll show you dynamic changes how it actually works. So, right, on my right hand side, I have the attacker's machine, that is my parrot, and I'm making a ping request on 106, correct? Right now it's working. But if you see on the left hand side, I have the victim, which is a bit smarter this time. I'm having, if I just simply drop the packet, you will see no response. See that the response stopped right away. See that? So that kind of things happens. If I reject the packet now, you see it says the destination port is unreachable. That means the system port is unreachable. The ICMP port is unreachable. That means the system might be active, but the port for ICMP is not available. So that is what is being portrayed. But if I want to tell the victim the host is not unreachable itself, that means the host is not even active. So what I can do, I can put a simple message like with reject with, and I can give a message specifically like destination host unreachable. That, what about that one? I believe. Let me check. ICMP host unreachable. Okay, my bad. Sorry. Look at that. So yeah, this is the document actually I was talking about. So I'll share with you. ICMP host unreachable. If you see, as soon as I hit enter, now the response changed. Earlier it was port unreachable. Now it is showing host unreachable. You see that? So now this will confirm, this will give an impression to the attacker that the host is not reachable. Additionally, what I can do, I can simply drop the packets and not even give any response to the attacker so that the attacker will think the machine is completely dead. Dropping the packet simply means not even accepting it. There is no more packets being transferred. no ping response coming out. After a few while, it will say ping timeout. So basically, that's how it actually works. So this way you can secure yourself and implement various kind of IP tables rule sets in your system. So that's how it works. If in case you implement some incorrect IP table form or incorrect IP tables rule set, you can simply flush the IP table rules basically. So how it actually works, IP tables hyphen capital F. Simple as that. As soon as I do that, make sure I implemented a rule set for ICMP just now that is dropping the packets. If I flush, it will remove all IP table protocols and it will start pinging the machine again. You can see that giving the ping response one more time because I removed the IP table and now it is giving the response just like a regular one. So this is how dynamically IP tables work, and this is how easy it is to implement. I mean, obviously you have to understand the functionality of how IP tables actually work and what are their syntax and different kind of things you can do with the help of IP tables. But once you already know about it, it's a really great thing to work with. And if you need help, resources, just let me know. This is how server and system security works. I've shown you how you can configure XAMPP, how you can monitor logs and stuff like that, and how you can secure your services and ports on a particular server on a particular system. And yeah, that's pretty much how it works. So this was about this session. So please wait for the another video. And thank you so much for having patience. Thanks.